Hi everyone, good evening all. So today we are going to solve problem number 60, that is on find the time constant for the given network. So this is the given network for us. For this given network we need to find the time constant. Let's try to see the procedure of finding the time constant here. You can see here and voltage source is there and resistors are there and inductors are there. Basically, the formula for time constant of an RL circuit is L by R. So this we are going to write on it as L equivalent divided by R equivalent. Okay. So first we need to find these values. Okay. So already from the problem itself, it's very clear the value of L equivalent is 1 Henry. Okay. So the value of L equivalent is equal to 1 Henry. Okay. So now we need to find out R equivalent. So the procedure of finding R equivalent is, so this 1 volt voltage source has to be short circuited. So if voltage sources are there, replace the voltage source and deactivate them. So deactivating a voltage source is nothing but making the voltage as zero, is indirectly short circuiting an voltage source. So if you have any current source, let us assume that you have a current source of 10 ampere, deactivate this current source. When you deactivate the current source, automatically the current becomes zero and the network act like an open circuit. Therefore current is equal to zero. Just keep it in the mind. If you have a voltage source, deactivate the voltage source, indirectly short circuiting. So deactivating the current source is nothing but making it open circuited. So now same we will follow here. And if you have any inductor, okay, just open circuit the inductor. If you have any capacitor, so inductor in farads, so inductor in Henry and capacitor in farad, just make both open circuited. If you follow these three techniques, then we can solve the problem in a better fashion. Voltage source has to be short circuited, current source has to be open circuited, inductor has to be open circuited, and capacitance also has to be open circuited. Now apply all this and let's try to find out R equivalent of the given network. So if you draw this initial network, so voltage source is there. I'm short circuiting the voltage source. I'm redrawing the network. This is 1 ohm and this is another one is 1 ohm. So this is 1 ohm and this is another 1 ohm and inductor is open circuited, and here we are going to find out R equivalent. Okay, so current flows like this and currents get divided. Whenever current gets divided, so between these two nodes, let's try to mark this node as 0 and this node as 1. Now I can say these two nodes are now connected in parallel. Why? Because the division of current is going to occur. These two are connected in parallel, so we are going to get only an single resistance, so which is nothing but we need to calculate R equivalent. So whenever these two are in parallel, parallel is product of resistance divided by sum of resistance, which is nothing but 1 by 2. 1 by 2 is nothing but 0.5 ohm. Okay, so therefore R equivalent from the problem is 0.5 ohm. Therefore the time constant tau is equal to L equivalent by R equivalent. So L is equivalent is nothing but we had already got given in the problem 1 Henry divided by R equivalent is 0.5 ohms. So which is nothing but 1 divided by 1 by 2, which is nothing but 2 seconds is the time constant of the given network. So this is the procedure of solving an given problem of finding the time constant. If you feel, so all these problems are very much important in gate type of competitive exams. If you feel my explanation is good and content is good, please give a like to the video and please share the content with your friends. And if you have any doubts, let me know in the comment section. I will answer your comment. And if you are watching the channel for the first time, subscribe to my channel with the name KV Tulasi. Thank you for watching. We'll meet in the another video. Yours